Today we're learning about key parts of a quadratic function. We're also going to start looking at the graphs of quadratic functions. Previously we solved quadratics, but we have not seen them on the graph yet. So a quick reminder, in a quadratic function, the greatest exponent is 2. These functions can have a quadratic term, a linear term, and a constant term. Okay, your quadratic term is always your term with the exponent of 2. Your linear term is always the term that has an exponent of 1. And then lastly, your constant term is the term with no variable. For this first set of examples, you are just asked to determine if the function is linear or quadratic, and then identify the quadratic, linear, and constant terms. So this is just making sure you understand what this function is above. Number 1 is in standard form, it is not in factored form. So we're going to have to multiply this out in order to determine what our function is. When we multiply this out, we distribute the first term to both terms in the second set of parentheses and the second term. X times 2x is 2x squared. X times negative 6 is negative 6x. 3 times 2x is positive 6x. And 3 times negative 6 is negative 18. At this point, the only common terms that I have are negative 6x and positive 6x. When I simplify this, I have 2x squared minus 18. Alright, so you always want your function in standard form in order to identify if you have a linear or a quadratic. Alright, because we have a squared term, anytime you have a squared term, you're going to have a quadratic function. And within the quadratic function, we need to list each term. I'm going to abbreviate my quadratic term as QT. And recall that the quadratic term is the squared term. So right here, that's my quadratic term. It's 2x squared. My linear term, abbreviated LT, is the term that has a variable with an exponent of 1. In my standard form equation right here, I actually do not have a variable with an exponent of 1, so my linear term is 0. And my constant term is the number by itself with no variable. Here we have a constant term of negative 18. Number 2, f of x is equal to negative 3 times x plus 1. We need to get this in standard form. Distribute that value of negative 3. We have negative 3x minus 3. So linear or quadratic. Well, we don't have a squared term. The highest degree that we have is this term right there. So this is a linear function. And knowing that this is a linear function, I'm going to identify my quadratic term, which does not exist, so it's 0. My linear term, that's this here, negative 3x, and my constant term is negative 3. All right, the graph of a quadratic function. Here is what the graph of a quadratic function looks like. It looks like a U. We actually talked about these earlier with the the family of functions unit. So we graph this function in the shape of a U. It does have some key parts. Two of the key parts that are important are the axis of symmetry. Actually, I'll highlight that in purple. And also the vertex highlighted in green. So the axis of symmetry is a line through the graph of the parabola. It's this line here. It divides the graph into two equal or two equivalent halves. Each side is a reflection of the other. Okay, the vertex, which I had highlighted in green, is where the axis of symmetry intersects the parabola. This happens at only one point, so it's down here, and this is called the vertex. Looking at and labeling key parts of a parabola. Okay, so we have our axis of symmetry, which we talked about previously. The axis of symmetry is the line right here that is equal distance from each side. It divides the parabola strictly or perfectly in half. Besides from the axis of symmetry, we just talked about the vertex, which is specifically a point where the axis of symmetry intersects the parabola. It's either the lowest point or the highest point on the graph. Some other key parts are the y-intercept. Y-intercept is the point where the parabola crosses the y-axis, and it can be found by substituting x equals 0 into the function. Right here is the y-intercept. Along with the y-intercept is its reflection, and the reflection is the same distance from the axis of symmetry. So let's say that the y-intercept is 2 units away from the axis of symmetry, then the reflection is 2 units in the opposite direction. And lastly, we have our x-intercepts. Our x-intercepts are where the graph crosses the x-axis, otherwise known as zeros or roots, and they can be found by solving for x. Here are the two x-intercepts. It's where the graph crosses the x-axis. For example set 2, we need to use the graph to identify the axis of symmetry, the x-intercepts are zeros, the y-intercept, and the vertex. Also, the directions tell us to label these on the graph. So I'm going to start with the axis of symmetry, abbreviating it as AOS. The axis of symmetry is the line where the parabola is divided into two equal parts. And I would say this happens right here. We also know that the axis of symmetry cuts straight through the vertex, which is the point where the graph changes direction. The axis of symmetry is always going to be read as x equals, and then whichever number it falls at. This right here is at x equals -1. It is a line in the coordinate plane. The vertex is what I just labeled. The vertex is right here. It is the point where the graph changes direction. In this case, this vertex is at -1, -4. That's the ordered pair of where the point is found. We also need to label our intercepts. So let's start with our x-intercepts. X-intercepts are where the graph crosses the x-axis. Our x-intercepts occur at the point -3, 0, and also a point at 1, 0. The y-intercept is where the graph crosses the y-axis. This point occurs at 0, -3. All right, follow along as I complete number 2. Next, we're going to look at our minimum and maximum value. These are exactly like they sound. So the minimum value is the lowest point on the graph. The maximum value would be the highest point on the graph. If you have a minimum, then the graph opens up because it has a low point. If the graph has a maximum, then the graph opens down because you have a high point. And just think about that logically. Right here, it goes to an absolute low and comes back up. That graph is opening up, but it has a low point. This graph reaches an absolute high, but it's opening down. That means you have a maximum. In either case, the y-coordinate of the vertex is the min or max value. Use a graph to identify the maximum or minimum value and label this on the graph. Number 1, this graph goes up, hits a high point, comes back down. So in this case, we're going to say that this graph has a maximum. And if this graph has a maximum, it occurs at the y-coordinate of the vertex. The vertex here is at 3, 5. The y-coordinate is 5. So there's a max value at 5. Number 2, this graph goes up, it reaches a low point. That right there is our minimum value. We can't have both, we either have a max or a min. The minimum value is at the vertex, which is 1, -4, and it is specifically going to be the y-coordinate. Here we would say we have a minimum value at -4. Like we earlier mentioned, the y-intercept is where the graph crosses the y-axis. And if you are calculating the y-intercept, then you need to substitute 0 in for x and you need to solve for y. If your function is in standard form, then your y-intercept is the constant value. That's just a helpful tip on these problems. Number 4 says to use the graph to approximate the y-intercept, then find the y-intercept algebraically. If I look at the graph, it appears that the y-intercept is right here. So I'm just going to say, graphically, it appears the y-intercept is at -2. Then the directions say to use algebra to calculate the y-intercept. To calculate the y-intercept, you need to use the fact that x equals 0. I have my function, f of x is equal to 6x squared minus x minus 2. Substituting 0 in for x. And when I do so, I have 6 times 0 squared minus 0 minus 2. This is equal to -2. So my y-intercept is located at 0, -2, which is the same coordinate we pulled off the graph, but make sure you know how to calculate it algebraically as well as identify where it is. And x-intercepts, or zeros, or roots, all of which are similar and are found the same way. These are where the graph crosses the x-axis, and this is what we spent the entire last unit finding. So last unit we were finding zeros of the function, and we learned how to do that using the factoring method, square roots, completing the square, and quadratic formula. So all of those values, or all of those topics, are showing us how to find the x-intercepts or zeros of the function. Set the function equal to 0 and solve. We have 4 methods. We have factoring, we have square roots, we have completing the square, and we have the quadratic formula. And on the front sheet of your packet, your note packet and your practice packet, there's a description of when you want to use each one of these. For this function, we're going to look at the graph, and I'm going to notice that I see a 0 here and here. I'm just going to guess where they are. So for this one, I'm going to guess that this is at x equals -1/2. And this one appears to be a little bit further than 1/2, x equals 2/3. Now that I guessed where they are, I need to prove, oops, spelling that wrong, where they actually are. I have my function, 6x squared minus x minus 2. I'm going to set this equal to 0. And I'm going to start by trying to use the factoring method. So I need to think what two factors multiply to equal -12 and the same two factors that add to equal -1. -12 is a times c, or 6 times -2. This is going to be -4 positive 3. We have 6x squared minus 4x plus 3x minus 2 equals 0. First group has a GCF of 2x. Left over is 3x minus 2. Second group has a GCF of +1, 3x minus 2. Let's write our GCFs as a group of 2x plus 1 and our common factor as a group of 3x minus 2. Set this equal to 0. Solve for each factor. So now that I've calculated these algebraically, you can see that my guesses were accurate on the graph. It's completely okay if they're not perfectly accurate, just as long as you give it a shot of identifying where they are on the graph and also calculating algebraically. When you write your x-intercepts, you do write them as an ordered pair. So I'm going to write this as -1/2, 0, and 2/3, 0. All right, for the last on your own section, here's my answer. You can look over that. If you have any questions on today's notes, please make sure you email me. We can set up an individual meet, or I can go over anything with you via email, whatever you guys need.